Welcome back to another episode of Data Science at Home podcast. I'm Francesco, podcasting from the office of Analytics Technologies based in Brussels City, Belgium. Finally back from holiday, and I hope all the listeners are back as well, just because I'm a bit jealous. If you're still there, lucky you, of course, but you still have time to listen to this show from the beach, probably. Again, lucky you, and now I'm jealous. Well, in this episode, which is actually part of a new series of the show, Data Science at Home podcast, as usual, the official website, you should know it by now, datascienceathome.com. And of course, we have a Discord channel as well as the newsletter. So all the links are, of course, on the official page. So feel free to subscribe. It's free of charge, no spam, just content and no hype. In this episode, I am going to talk about, well, something extremely important, which is your kids. Yeah, the tiny human eating chips in front of Minecraft right now. Probably not, there are better games these days, but in fact, they might be the next GPT engineer, if you know what I'm talking about, or the next rage quitter, if you know what I'm talking about. Either way, we need to talk, right? So stay cool, even at the beach, and this episode is for you. And indeed, welcome back to Data Science at Home. I'm your host, Francesco, and if you're new here, this is the show where we talk about all things AI, just without the hype. Okay, so today we are about to dive into the beautiful chaos that is teaching kids how to code in 2025. And it's such a beautiful topic, but also a very challenging one because things have changed a lot. Since when? Since when I learned how to code, for example, which is more than 30 years ago. So today's episode is titled, Your Kid Should Learn to Code. I would say even if they rage quit. And yes, I said rage quit because apparently throwing a Nintendo Switch across the room is now considered a learning milestone. And believe me when I say that, it really, really happened. Okay. Now, before all the helicopter parents start writing angry emails about how their precious little snowflake would never rage quit, just relax. Your kid probably rage quit breakfast already this morning because their cereal was not arranged in perfect geometric patterns. All right? It's fine. We're all fine. We're gonna be fine. Right? So today we talk about why your 8-year-old freaking out over a for loop might actually be the best thing for the future career. And here is a hint. It has nothing to do with those dusty computer science textbooks that are, decaying in those school cupboards or whatever. In fact, how can I put this gently? What I'm about to say will not exactly be music to the ears of schools, teachers, all the folks who have built entire careers around these institutions and educations in general. So grab your coffee or your beer or your cocktail, probably if you're at the beach. Hide your kids' gaming controllers for the next 30 minutes, and let's talk about why modern education is basically teaching kids to code like it's 1995 and what we can do about it. So let's get started and let me address the usual elephant in the room. And by elephant, I mean that computer science teacher who learned Java back in 2003 and still thinks it's cutting edge technology, right? It never was, dude. Believe me, it never was. Now, I'm not here to bash teachers. I come from a family of teachers. My father was a teacher, my mom was a teacher, my sister is a teacher, and I hope our kids will never be teachers. Well, time will tell. But teachers in general, they're doing their best with the resources that they have at their disposal, which is pretty much, 1980s Soviet factory equivalent. Most programming education today is like teaching kids to drive by just showing them a horse and a buggy manual, right? That's my outstanding confession about things I've seen and heard. So I was at my nephew's place very recently. I went on holiday, southern Italy, very beautiful place, very nice kids. My nephews, of course, as everybody's nephews, and I'm the type of the type of uncle who has been dealing with computers since his own life, and I'm the only one in the family that actually is bringing some fresh tech and tech education to the kids, right? So I have this massive responsibility in my family, so to speak. And I believe that there are many others out there. Millions of people have this responsibility. And believe me when I'm saying this, it is a massive responsibility because the world is turning into a different direction than we planned. Um, and now it's the time to learn, or at least set the direction for your kids to learn for their future and for their benefit. It's not just about career, as I will explain in this episode. All right. So back to my adventure. I was at my nephew's place, and you know, I asked about the typical computer science class where you know kids are learning stuff that matters to me, and the answer was like a dumb exactly. Well, first of all, there was no computer science class. The kids are 10. So whatever they do is kind of an extra thing, extra to the typical educational plan they have at school. And in the best case scenario, these kids were learning to make websites using Dreamweaver or something like that. So this is happening in 2025. Um, I nearly had a shock, you know, to hear this. Um, the teacher, you know, she's a sweet lady, probably great at teaching fractions. She was showing kids how to drag and drop buttons like, they're assembling furniture from IKEA. And meanwhile, these same kids go home and build complex automation systems in Minecraft without knowing, of course. Um, that would make definitely senior DevOps engineer weep with jealousy. Now, not to mention that most of these kids are very active video gamers, and my nephews included. They're actually pretty good, especially one of the two. I'm not going to make the name because, they're probably listening. uh, Now, when someone is good at playing video games, it triggers me because it's exactly how these kids show their potential. Because there are a lot of things in a video game. Uh, there is curiosity and many other properties and features or characters of an individual who wants to spend time or wants to have that experience of playing a video game. But of course, it's my personal point of view. I was a nerd. I'm still a nerd, and I don't expect my nephews to be nerds. But I think that playing video games the right amount can unlock certain features that other kids would not, or it would take longer, or they need other experiences to unlock the same features. That's my personal intake. So even though I agree that the video games of today are, kind of a stripped version of the brutal games that we had back in the days, and I speak about the 80s and the 90s. For example, tutorials these days are way easier, while back in the days we had to discover how to play the game by just playing it. And of course, a lot of trial and error. So with these games, back in the 80s and 90s, we learned how to fail and start over and never give up. And today that component, in my opinion, is no longer there, or it's less present, and at least not in the same vigorous amount as the 80s and the 90s. But with this said, the existence of the existence of video games is something that it can trigger several properties and characters and features in an individual. Now, back to the education system about computer science and programming. There is a massive disconnect. That's what I found, at least in Italy, in southern Italy, which is definitely not known to be one of the high tech places in the world. So probably my conclusions will be, hopefully, are quite local to southern Italy. But if there are analogies in the country where you grew up, or where your kids are growing up, please let me know with some comments or just get in touch with us because we want to know. So, generally speaking, schools are teaching kids to think like computers from 1985, okay? While the kids are already thinking like AI systems, right? It's like teaching someone to paint by making them memorize the chemical composition of pigments instead of just handing them a brush and saying, go and make something beautiful, right? That's the conclusion that I have about the way computer programming is being taught today. Now let's talk about attention spans. So every parent I know, my sister included, is convinced that their kid has ADHD, right? Attention deficit disorder, right? Because my little kid cannot sit through a 45-minute lecture about variable declarations. Well, no shit. Timmy or your kid doesn't have ADHD. Your kid has a functioning brain that's adapted to the information age. And guess what? The information age is full of distractions. Well, we call it distractions, but it's like full of signals, right? To be processed. So kids today process information like hummingbirds on espresso. They can absorb complex gaming mechanics in minutes. They can master TikTok algorithms by Tuesday and understand NFT marketplaces better than most economists, right? And I'm not exaggerating now, also due to the fact that we really have a lot of incapable economists nowadays, but that's a different story. Now, put the kids in front of a traditional programming lesson, and suddenly they are distracted. And let me quote on that. So, you know what's actually distracted? Teaching programming like it's Latin poetry, right? The typical teacher will start with, kids, today we shall conjugate the beautiful syntax of Java arrays. Right. Meanwhile, the kid in the back row just built a Discord bot that orders pizza when his mom texts dinner time. What's the beautiful irony of this? Well, these so called attention deficit kids are actually attention surplus. They are parallel processing information streams that would crash most adult brains. And you know why? Because adults' brains are not prepared to that. They are not broken, the teaching methods are broken. So here's when it gets interesting. While schools are teaching kids to print hello world like it's some profound spiritual achievement uh, of the back of the past, in fact, that's how we learn programming languages, these same kids are mastering computational thinking through games that would make computer science professors cry into their tenure coffee. That's what I usually do. Now, take Roblox, right? And as I said, Roblox is an educational. Now, fight me. Kids on Roblox, it looks like they're on drug, but they're not. Kids on Roblox are learning a lot of things. They're learning event driven programming through game mechanics. They're learning conditional logic through game rules. They're learning loop structures through repetitive tasks. They're learning API interactions through multiplayer features. They're learning resource management through virtual economies. And of course, user experience design through game creation and visuals. And they're doing it while having fun, definitely more fun than a data scientist who just discovered that they have been working or they found out the cleanest data set ever, which, by the way, never happened. If you think about Minecraft, don't get me started. Kids building redstone computers in Minecraft are essentially learning digital logic circuits without knowing, right? They're creating Boolean algebra systems for fun. For fun, right? Meanwhile, electrical engineering students are paying 50 grand a year to learn the same concepts through textbooks that make watching paint dry seem thrilling. Now, of course, I'm not saying that education, or well, you don't have to spend money for education, quite the opposite. I'm not saying that university is no longer useful, quite the opposite. I'm saying that there are so many more signals to educate your kids from today than we had in the past. And some of these signals are hidden in the things that you as a parent are probably criticizing. So here's the secret sauce that the educational industrial complex doesn't want you to know. The moment you make something educational, right, you have killed already 90% of its learning potential. I'm going to repeat this, especially to my parents who were teachers and they come from that school of thought. And I'm repeating this also to my sister who is playing and working in this very educational system. The moment you make something educational, you have killed 90% of its learning potential. Kids can smell educational content from 3 blocks away. The minute you say, today we're gonna learn something or we're gonna learn valuable programming skills, their brains immediately activate defense mode. It's like telling someone, this medicine tastes great, right? Nobody believes you. Instead, try a revolutionary approach, which is not so much revolutionary, but I would love to uh, give some details on that. Make it about solving real problems they actually care about. So, for example, your kid loves TikTok. Okay, teach them to scrape TikTok's API and gather data. They are obsessed with their cat or pet hamster. Help them build a hamster activity tracker. They think you are embarrassing on Facebook. Cool. Teach them to build a parent free social network. The magic happens when kids forget that they are learning because they are too busy building something that matters to them. It's like sneaking vegetable into pizza, right? I've seen this, for dogs or, even humans. Except that instead of vegetables, it's computational thinking, and instead of pizza, it's well, actually, it's still pretty much pizza. You get the point, right? Now, here's where traditional education really face plants. They try to teach fundamental concepts through abstract examples. They have zero connection to reality. That happened to me back in the days at school, and that's why majority of the things that I learned and I still remember and actually built a career around that are the things that I learned at home, not at school. So today, you have the typical teacher who will, gather the children and say, "Kids, today we'll learn about recursion by calculating the factorial of a number." Do you remember that? Seriously. I mean, this shit should be illegal. Also, Fibonacci should be illegal. You know, Fibonacci series and recursion? Fuck it. Really, you're going to teach recursion through factorials in 2025 to kids who live in a world where everything is recursive. Their Instagram feed is recursive. Their YouTube recommendation is recursive. Their gaming achievements is recursive. All right? Instead, explain recursion through something they understand. You know how when you look in two mirrors facing each other, you see infinite reflections? That's recursion, right? Each reflection creates another reflection following the same rule. Boom. That's done. That's how you explain recursion to a kid. Now let's build a program that creates infinite memes. That's recursion. You want to teach kids, I don't know, loops? Okay, skip the boring counting examples. Forget about let's count the first n numbers. Who gives a shit? Really. Show them how to build a program that automatically likes every dog photo, or better, cat photo on Instagram. Okay? Suddenly, everyone understands why loops are useful and also how Instagram bots work. You want to learn about data structures? Forget arrays of numbers. Build a program that organizes their Spotify playlists by mood, energy level, and whether their ex little girl would like it. Now they get why data organization matters. The key is connecting abstract concepts to their concrete world. It's not dumbing down, it's actually smartening up your teaching. And that's why I think teaching methods today are obsolete. Well, in fact, they were already obsolete 20 years ago. My sister and a few other parents always ask me, when should my kids start learning to code? And I always give them the same answer since years. Well, when did they start asking why questions? Because programming is essentially a professional question asking, right? It's a taking a problem, breaking it down into smaller questions, and then teaching a computer to answer those questions, right? The statements, the code blocks, and all that stuff, the functions. If your kid can ask, but why can't I have ice cream for breakfast? Well, then they can learn programming logic. I've seen 8-year-old kids and nephews grasp conditional statements better than some junior developers. If homework is finished, then iPhone time, else no iPhone time, right? That's literally an if else statement, which is 80% of any code base in the world. And they understand it perfectly because the stakes are clear. Now, the sweet spot seems to be around 7, 10-ish year old, when they're old enough to handle abstract thinking, but young enough that they haven't learned to be afraid of breaking things. That's also another problem of education, stigmatizing mistakes and errors. But that's probably a different story for another episode. So at this age, 7 to 10 years old, they'll click every button, they try every combination, and they discover edge cases that QA testers would definitely miss. Of course, they don't rationalize as much as they should because they are young, but they try. They click every button, they break things, and they try to exhaust the number of combinations. Now, there are problems where exhausting the number of combinations is not possible, and that's when you need to think for something, smarter, because you cannot explode all possible combinations. Plus, they have zero preconceived notions about what's supposed to be hard. Uh, Adults approach programming like, oh no, this is technical and scary. How many times have you seen that? And I had that myself on my skin. Some kids approach it like, oh cool, another puzzle to solve. I mean, it's a different approach, it's a different mindset. Many other kids don't do that. Okay? And what happens, let me tell you about what happened to me with pointers in the C programming language. So we always had people around telling how difficult pointers were. And why was that? Is because pointers were just a bit more abstract than data structures, for loops, and control flows, for example. All these concepts were kind of okay to grasp for a kid, but pointers were a bit more abstract than those because it's something that points to another cell that is containing an address that points to something else. That's what pointers is about. They wanted to convince me that pointers were difficult. And indeed, they are a bit more abstract than other concepts, but the adults around me when I was a kid, they did their best to convince me that pointers were difficult. Now, when you tell me something about, how challenging something is, me personally as a character, I react to that and I say, "Fuck yeah, I'm gonna try to fix this. I'm gonna try to solve this." But that's me. There are many other kids that can do that, of course, but there are many, many other kids that give up and they say, "Oh, you told me it's difficult, it's scary. I'm gonna skip this," and they will never learn pointers. And that's why a majority of these kids started playing with Python, which is the most terrible thing that can happen to your life after Java, of course. Now, jokes apart, you get my point, right? Don't scare your kids. Uh, don't scare your kids with something that you don't even know, probably. The way their brain works is not exactly how the brain of an adult works. And that's simply because they come from a different generation. Remember, we keep evolving as humans, as organisms, but we also keep evolving as behavioral machines because of what is happening around the world. And what is happening today around the world is not what it was happening 30 years ago. In fact, it's not what was happening 5 years ago. So play with that. So another thing that really intrigues me about kids is that they have zero preconceived notions about what's supposed to be hard. And that's beautiful because uh, if you don't tell them that something is hard, they will not think. They will just try. So don't tell them that something is hard. Now, there is another secret that I want to reveal, secret of course, quote unquote. It's never too late to start. I've tried to teach the basics or at least speak about, computer programming to a 60-year-old grandparents and they bring something kids don't have, which is patience and real-world problem-solving experience. Although they, do tend to ask if they, can print out the internet for safekeeping. Actually, that's my dad. If he cannot print the internet, he is currently pretending to handwrite it several years now. That's the problem of adults, and that's the problem of grandpas. They want to, have something tangible, and they want to have whatever they see on screen, also, physically, something they can touch, uh, or they can interact on a, with their body, with their hands, right? There is some form of embodiment request from grandmas and grandpas. But okay. Now, about the controversial part of this episode, which is the rage quitting. I think that rage quitting might actually be the best thing your kid can do for their programming education. And why is that? Well, I'm not advocating for giving up, of course. Here's the thing about programming. Programming is basically professional problem solving mixed with professional frustration management, right? Every programmer has spent hours debugging code only to discover the error was just a missing semicolon, right? We've been there. Majority of the developers have been there. Every data scientist has built a beautiful model only to realize that they were training on the wrong data set, right? We have been there too. Frustration isn't a bug in the learning process, it's a feature. So when kids rage quit a programming project, they're actually learning several critical skills that they would not learn otherwise. For example, problem recognition. Hey, this isn't working and I need to stop before I break something or someone's face, right? There is emotional regulation. Hey, I'm too frustrated to think clearly right now. I'm gonna take a break. There is strategic retreat. Maybe I should try a different approach. That's what I think. They learn resilience building. Hey, I'll come back to this when I'm ready, right? So these are literally the same skills that senior developers and pretty much any human being use when they walk away from a tricky bug. They go get coffee and come back with a fresh perspective. Now, the difference is that kids haven't learned to hate themselves for taking breaks. They rage quit, they go play with Legos for an hour, then they come back and solve the problem in 5 minutes because they know how to master rage quit. They know that. Meanwhile, adult programmers sit there for 6 hours straight, getting increasingly angry at their code, their life choices, probably their wives or husband, and their entire concept of computers. Kids are actually modeling healthy problem solving behavior. Maybe we should be learning from them and not teach anything to them. But in addition to this, every time they come back after rage quitting, they are proving to themselves that they can overcome challenges. And that's why I think that's not failure, that's building anti-fragility. So here's what I've learned after dealing with code and teaching others. The goal isn't to create little programmer robots, okay? The goal is to teach them how to think systematically about problems. And I'm very cautious when I say this because programmer robots is what we will have soon in the very near future because of AI. So programming teaches logical thinking, um, but it also teaches how to break complex problems into manageable pieces. It also teaches how to test ideas systematically. It teaches you how to iterate and improve solutions, optimization. It teaches how to collaborate with others and also with AI. Soon you will, more and more. And it will also teach you how to learn from failure without taking it personally. So these aren't programming skills, these are life skills that happen to use programming as the delivery mechanism, right? I repeat, these are not programming skills, these are life skills that happen to use programming, the delivery mechanism. And in a world where AI is writing code, the valuable skill isn't knowing syntax, it's knowing about how to think about problems, how to communicate with systems, how to bridge the gap between human needs and computational solutions. Your kid doesn't need to become the next Linus Torvald. right? For those who know who this guy is. But they should understand how to think computationally because everything around them is becoming computational. Their car, their house, their job, their relationships, it's all becoming data driven and algorithmic. Teaching them to code isn't about preparing them for a programming career. Nobody cares of building an army of programmers in the near future, but it's about preparing them to be thinking humans in an increasingly algorithmic world. It's teaching them about life. So there you have it, folks. Your kids should absolutely learn to code, not because they'll become the next tech billionaire. They will not. Very unlikely that will happen, but because computational thinking is becoming as fundamental as literacy, if literacy was ever. So let them rage quit, let them get frustrated, let them build ridiculous projects that make no sense to you but perfect sense to them. And for the love of God, let them learn through games, memes, and whatever else captures their attention for more than 5 seconds, because that's the time span today, right? The future doesn't need more programmers who learned Java in a classroom. We never cared of that shit. It needs creative problem solvers who understand how to think systematically and communicate with increasingly intelligent systems. And of course, if your kid's first programming project is a bot that automatically orders pizza when they're sad, congratulations, you have raised a future tech leader. Now, before I sign off, remember the best way to predict the future is to build it. And the best way to prepare your kids for the future is to teach them how to build it too, even if they throw a few controllers in the process on the wall. I'm Francesco, and this has been Data Science at Home podcast, and I'll see you next time for another deep dive into the beautiful chaos of our data-driven world. Keep coding, keep questioning, and of course, keep being gloriously human in an increasingly algorithmic world. Oh, and parents, if your kid writes a program to do their homework, don't stop them. Throw a party. That's not cheating, it's being smart. The future belongs to people who let computers handle the boring stuff so they can work on the fun problems. Bye.